Welcome back to Kiersti's virtual classroom. This is a Kahoot review for Geology 1. Okay, so this is for the final examination. Alright, so let's get going. So the first question is, all maps show elevation. Is this true or false? This would be false. Not all maps show elevation. Some only show streets and major landmarks. Some only show the geology. Topographic maps are the maps that show elevation. Alfred Wegener founded plate tectonics. True or false? That would be false. Alfred Wegener's founded theory was continental drift, not plate tectonics. Plate tectonics was a combination of Arthur Holmes and Harry Hess. A raised relief map is a 3D representation of topography scaled down. This is true. So the raised relief maps are the maps that you can run your fingers over, and they have the highs and the lows. A verbal scale on a map is depicted by a bar and distance relationships. This is false. Remember, the verbal scale is the scale that says 1 inch on this map equals 32 feet on the ground. Okay, the bar and distance relationships are the bar scale. Excuse me. Everyone has access to clean, potable water. This would be false. We talked about this heavily with groundwater and surface water. So not everybody can turn on their tap and have clean, potable water come out of it. Some people have to go get it or buy it. The largest plate on Earth is the Pacific Plate. This would be true. Of all the tectonic plates, the Pacific Plate is the largest. New crust is created at transform plate boundaries. This is false. New crust is created at divergent plate boundaries where two plates pull apart and there is a crack left in the crust where mantle material can fill in, forming new crust. At transform plate boundaries, all they do is slide past each other, which creates horizontal offset on the surface. The epicenter of an earthquake is the location of the earthquake's origin on the surface. True or false? This would be true. So the epicenter is where the earthquake originates on the surface, and the focus is the origin of the earthquake at depth. Seismic waves will move through granite faster than unconsolidated sand. This is true. So the more compact the grains are, or the tighter the rock is, like granite is a very solid, minimal pore space rock. So seismic waves are going to move through it much faster than an unconsolidated sand, where it will bounce around between the pore spaces a lot more. Brittle deformation causes folding. This would be false. Remember, brittle and ductile deformation. Brittle is breaking. Okay, so brittle would be false. Ductile is folding or bending. Okay, so ductile is bending, brittle is breaking. Breaking is faulting, bending is folding. Earthquakes kill people. This would be false. Earthquakes do not kill people. Falling objects, falling buildings, falling bridges, all of those things will kill people. But the earthquake itself does not. It's an indirect result. The Benioff zone is the zone of earthquakes on the top of the subducting oceanic slab. This is true. So just remember, the Benioff zone is the zone of earthquakes at the top of the subducting oceanic slab in a subduction zone. Tsunamis are an indirect result of fault motion. This is true. So tsunamis can occur if there is fault motion underwater. That result is from the displacement of water, and that water has to go somewhere, and that'll be presented on coastlines as tsunamis. Metamorphism occurs below 50 kilometers at depth. This is false. Metamorphism occurs between 10 and 50 kilometers at depth. Below 50 kilometers, your felsic rocks or minerals start to melt and they become igneous. Any rock can be made from any other rock type. This is true. This is why it's called the rock cycle. So any rock can be made from any other type of rock. Chemical weathering alters the rock physically. See, false, here's some keywords here. Chemical and physical are different. So chemical weathering would not alter the rock physically. It would alter the rock chemically. Physical weathering would alter the rock physically. A rock that is fully melted is only metamorphic. This is incorrect because metamorphism occurs with heat and pressure, and the rocks do not fully melt when they are metamorphosed. Rocks that are fully melted are igneous rocks. As depth increases, pressure decreases. This is false. As depth into the earth increases, pressure also increases, and so does temperature. Foliation occurs in metamorphic rocks only. This is true. You will only see foliated minerals in metamorphic rocks. The difference between breccia and conglomerate is grain size. This is false. The difference between a breccia and a conglomerate is not the grain size, it is the rounding of the grain. So in a conglomerate, the pebbles or the cobbles in the rock are rounded, and in a breccia, they are angular. Okay, so it's the angularity rounding that is different between the two. Who coined continental drift? Is this Alfred Wegener, Harry Hess, Thomas Edison, or Charles Darwin? This is Alfred Wegener. So continental drift was coined or founded by Alfred Wegener. What is the composition of the continental crust? Is it gneiss, basalt, granite, or pegmatite? Continental crust is made up of granite, primarily. What is the composition of the oceanic crust? Gneiss, basalt, granite, or pegmatite? This one is basalt. So the continental crust is made up of granite, and the oceanic crust is made up of basalt. What is the depositional area of a meandering stream? The point bar, the cut bank, the point bank, or the cut bar? That would be the point bar. So the depositional area of a meandering stream is the point bar. This is all of the inner curve. So when it's going around a curve, all of the inside of the curve are where the point bars are, where deposition occurs. What is the cause of a cone of depression? Overpumping, dam removal, infiltration of water into the ground, or none of the above? This would be overpumping. So the more water you pull from the groundwater, the more likely you're going to get a cone of depression. So overpumping will lower the groundwater table, and it will cause a cone of depression. What is a confined aquifer? An aquifer that hosts the top of the water table, an aquifer that lies below the water table, none of the above, or an aquifer that is surrounded by layers. It will be an aquifer that is surrounded by layers, hence the term confined. It is confined by layers. What marks the water table? The top of the zone of saturation, the top of the zone of aeration, the top of a confined aquifer, or none of the above. That would be the top of the zone of saturation. What is a contour line? Exact elevation, lines that connect areas of the same elevation, lines that dictate the location of streams, or none of the above. This is lines that connect areas of the same elevation. So remember, contour lines are the lines on a topographic map that show you where areas of the same elevation can connect. What is a contour interval? The difference between contour lines, the difference in slope, none of the above, or the interval of time between elevation measurements. This is the difference between contour lines. Which of the following controls the velocity of a stream? Smoothness, shape and size, gradient, or all of the above? All of the above. So the smoother the channel, the shape and size, so the smaller and more narrow the channel is, and the gradient, if that's steep, the stream can move really quickly, right? So all of these things will contribute to the velocity of a stream. What do closely spaced contour lines mean? That you have a valley, a steep slope, a cone of depression, or a hill. So in general, they mean that there is a steep slope. So closely spaced contour lines, steep slope. Further spaced contour lines means it's a gradual slope. When India collided with Eurasia, what did it produce? The Appalachian Mountains, the Himalaya Mountains, the Alpine Mountains, or India did not collide with Eurasia? The Himalaya mountain ranges. So India collided with Eurasia and created the Himalaya. At which of the following locations is the youngest rocks? On the continents, the oceanic ridge, the ocean basin, or the continental shelf? The oceanic ridge, because this is where two plates are pulling apart in a divergent plate boundary. Material is filling in the void that is created from the two plates diverting, and the youngest rocks are then created there. What controls ground shaking? Proximity to the epicenter, energy released, subsurface geology, or all of the above? That'll be all of the above. So the closer you are to the epicenter, the greater the energy released, and the weaker your subsurface geology is, the greater the ground shaking will be. What type of deformation causes folds? Brittle, ductile, driddle, or buctile? So that would be ductile, right? The last two are not even words. Brittle is breaking, ductile is folding. P wave is what type of motion? Is it a shear, compressional, shear and compressional, or tension? It's a compressional or a push-pull. Okay, P wave is compression or push-pull, which are basically the same thing. And then an S wave would be shear. S wave is what type of motion? Oh, there's your answer. A tension, shear and compressional, compressional, or shear. So an S wave is a shear motion. What is crystal form? The way the mineral forms or grows, the way the mineral breaks, the way light reflects off the mineral, or the robustness of a mineral to other substances. Crystal form is the way that the mineral forms or grows. Once it's broken, it no longer looks or holds its crystal form. What are two types of dip-slip faults? Normal, reverse, strike slip, or both A and B? That would be pretty easy because it's looking for two types, and these are single answers, so it has to be both A and B. Normal and reverse are your dip-slip faults. What stresses are associated with dip-slip faults? Compression, tension, shear, or both A and B? Again, you need there are two different types, so it's both A and B. Compression is associated with reverse faults, and tension is associated with normal faults. What are the stresses associated with strike slip faults? Compression, tension, shear, both A and B. That would be shear only. Strike slip faults are driven by shear stress. What type of fault is the San Andreas? Right lateral, left lateral, reverse, or normal? It is a right lateral strike slip fault. What do we use to record the waves of an earthquake? A magnetic declinator, a compass, a seismogram, or an iPhone? That would be a Where is the highest earthquake hazard in California? Fresno, Yosemite, LA, or San Francisco? That would be LA is currently the highest earthquake hazard. Why are the highest recorded earthquakes found near subduction zones? The origin of the earthquakes are deeper, the origin of the earthquakes are shallower, the origin of the earthquakes are all the same, or none of the above. The origin of the earthquakes are deeper, so the deeper the earthquake originates, the stronger or higher magnitude earthquake you're going to have on the surface. What are the criteria for a mineral? Naturally occurring inorganic, solid, crystalline structure, and definite chemical composition, or all of the above? That'll be all of the above. It has to meet all of those criteria in order for it to be a mineral. How does lag time change further from the epicenter? So it increases, decreases, stays the same, or increases rapidly and then decreases. This would be increases. So the further you move away from the epicenter, the further your lag time will be apart. So it increases the further you get away from the epicenter. What is liquefaction? The waves of energy. Soil substantially loses strength and stiffness due to ground shaking. A tidal wave is a series of waves in a water body caused by fault motion. Any ground shaking in bedrock. So this is when soil loses its strength and stiffness due to ground shaking and it becomes basically like quicksand. What three field tests are used to test a mineral for hardness? Fingernail, glass, copper penny, all of the above. All of the above, it's asking for 3, and it listed 3 and then gave you an all of the above. How could you distinguish quartz from fluorite? Color and hardness, hardness and streak, hardness and cleavage, cleavage and streak. Hardness and cleavage, quartz is much harder than fluorite. Quartz does not have cleavage and fluorite does. What is a result of confining pressure? Foliation, fractures, melting, or none of the above? None of the above. So foliation is probably something you were thinking about. Confining pressure is pressure from all sides. So none of these things would necessarily occur in confining pressure. But directed pressure or pressure from two sides, differential pressure, will create the foliation in a metamorphic rock. Clastic sedimentary rocks are primarily classified on the basis of grain size, degree of sorting, angularity, or mineral composition. So the first thing you look at here is grain size with clastic sedimentary rocks. Does it have sand, silt, clay, or gravel in it? The majority of the rocks found at the Earth's surface are sedimentary, volcanic, plutonic, or metamorphic. Most of them are sedimentary rocks. Most rocks are going through the weathering process and are either sediments or becoming sedimentary rocks. Which type of weathering process is happening to minerals or materials when they rust? Hydrolysis, oxidation, hydration, or dissolution? That would be oxidation. So when they're oxidizing, they are rusting. Which type of volcano produces basalt? Shield, composite, caldera, plutons. Shield volcanoes create basalt. What are the two types of Hawaiian lava? Papa and O'o, A'a and Pahoehoe. Papa and Pahoho, A'a and O'o. That would be A'a and Pahoehoe are the two types of Hawaiian lava. What controls viscosity? Iron, silica, oxygen, or sulfur? That would be silica. Silica controls viscosity of a lava, along with gas. But the primary component would be silica. The holes in a vesicular igneous rock like pumice are likely from Silica content, gas in the lava, crystals that dissolved, or minerals that never crystallized. That'd be the gas in the lava. So it holds space in the rock, and when the rock crystallizes and solidifies, the gas then escapes and leaves holes. Individual layers of sedimentary rocks are called graded beds, cross beds, ripples, or beds. So here we're just talking about sedimentary beds, layers of rock. Grains become rounded primarily during weathering at the outcrop, transportation, erosion, or deposition. This occurs mostly during the transportation stage, where the grains are taken from their source to their depositional area. So this is where most of the rounding will occur. Which transport medium carries the largest particles? That'd be ice, water, wind, or all of the above. That would be ice. So ice can carry the largest particles. Ice being glaciers, right? Not like ice from your freezer. It is unusual for blank to carry grains larger than sand. Ice, water, wind, or gravity. That would be wind. Wind does not typically carry grains larger than sand. What is the relationship between texture and cooling rate? Larger grains are from slower cooling. Larger grains are from faster cooling. Smaller grains are from slower cooling, or none of the above. Larger grains is slower cooling. Smaller grains is faster cooling. Ripples, dunes, and crossbeds are sedimentary structures that can be used to help determine what? Wind direction, current direction, past environments, or all of the above. That would be past environments. Oops, I clicked on the wrong button. That would be past environments. So in general, all of these things will tell you something about the past environment of the sedimentary rock. Graded beds tell geologists that turbidity current deposited these beds, depositing finer material first. Turbidity current deposited these beds, depositing coarser material first. Slurry deposited these beds with little sorting, or density current deposited these beds, depositing finer material first. That would be turbidity currents deposited these beds, depositing the coarser material first. Remember, the graded beds are when you see the coarser material going upwards to finer material, and this happens in a turbidity current after a submarine landslide underwater. And so everything gets thrown up into the water column, and then it separates out and falls down by density. At what depth does a metamorphism occur? 7 to 45 kilometers, 4 to 10 kilometers, 25 to 50 kilometers, or 10 to 50 kilometers. That would be 10 to 50 kilometers is where metamorphism occurs. Which type of rock is derived from the highest viscosity lava? Rhyolite, basalt, granite, or andesite? That would be rhyolite. So the highest viscosity lava, that already rules out granite because granite doesn't come from lava, it comes from magma cooling below the surface in a pluton. So we've got rhyolite, basalt, and andesite. Rhyolite has the highest viscosity with the highest silica content. Why do Hawaiian volcanoes have broad, gentle slopes while Mount St. Helens has narrow, steep slopes? The Hawaiian volcanoes have a lower viscosity. Hawaiian volcanoes have higher viscosity. Mount St. Helens has a lower viscosity, or none of the above. The Hawaiian volcanoes have a lower viscosity. Mount St. Helens has a higher viscosity, so it's going to plop down kind of like mayonnaise and kind of pile up after a while. And the Hawaiian viscosity is similar to something like honey, where it will flow out and fan out into these broad, gentle slopes. What is contact metamorphism? Occurs from subduction zone burial, occurs from hydrothermal vents at ocean bottom, occurs where magma plume is upwelling, or none of the above. So this occurs when a magma plume is upwelling, and everything that comes in contact with that magma plume will metamorphose. What drives recrystallization? Depth, pressure, heat, none of the above. Heat drives recrystallization in a metamorphic setting. So when rocks are being metamorphosed, if there is not a lot of heat present, you won't see a lot of recrystallization. They're just going to deform if there's just a lot of pressure there. What does directed pressure result in? Foliation, fractures, hardened minerals, or melting? Foliation. Remember, directed pressure is pressure from just two sides on the rock, and that creates parallel alignment of minerals perpendicular to that line of stress, which is foliation. Which of the following is not a texture of an igneous rock? Pyroclastic, glassy, waxy, vesicular. Waxy. Waxy is a texture of, it's a luster term for minerals, but it is not a texture of an igneous rock. A rock that is crystallized by a rising magma plume as a result of regional metamorphism, hydrothermal metamorphism, contact metamorphism, or none of the above. It's kind of a repeat question, but this is contact metamorphism again. What hazard is associated with shield volcanoes? Ash, lava bombs, lava flows, or all of the above? Mostly lava flows. There's not a lot of ash or lava bombs that are ejected from shield volcanoes. These are passive eruptions, so mainly what you're worried about is the lava flow. What hazard is associated with composite stratovolcanoes? Ash, pyroclastic flows, lahars, or all of the above? That will be all of the above. Composite stratovolcanoes have a lot of hazards associated, and all three of these are hazards of a composite strato eruption. Which volcano type is the most catastrophic? Shield, composite, strato, or caldera? Caldera is the most catastrophic eruption. A sandstone containing T-Rex bones would likely have been formed in deep marine, shallow marine, terrestrial, or a lake bed. Somewhere terrestrial for sure because T-Rex walked on land. A well-sorted sandstone with asymmetric ripples was most likely deposited as sand by a river, glacier, beach, alluvial fan. So key here is asymmetrical ripples, so we're looking at something like a river. If it said symmetrical ripples, you're looking at something more like a beach where you have oscillating current back and forth. What is the most common trigger of landslides? Human activity, temperature change, climate, precipitation. That will be precipitation. It is the #1 trigger for landslides. The age of the Earth is believed to be 500 million years old, 6,000 years old, 65 million years old, or 4.6 billion years old. 4.6 billion years old. What group of organisms flourished after the extinction of the dinosaurs? Reptiles, insects, mammals, or fish? Mammals, that would be us. We flourished after the extinction of the dinosaurs. Which is older, B or C? So looking at this graphic, is B or C older? That would be C. So if we look at this diagram here, B is a fault that cuts through C and is offsetting it. So that means that C must be older than B. Which is older, A or C? Okay, so we look at this. We've got A up here, and then we have C down here. Which is older? That would be C again. So A is a layer that's much higher than C. So as far as we know, A should be younger than C. Which is younger, B or D? Here we've got B is this fault, and D is this intruding Pluton. So B or D is younger. So D is younger. So you see how D comes and crosses over B. This is the cross-cutting relationship. B is underneath and is not affecting D, so D must be younger than B. What type of fault is B? So we're looking at B here. You can see the offset of C. So what type of fault are we looking at? Normal, reverse, strike slip, or thrust. So this would be a reverse fault, and we know this because if you drew Homer in here, your little stick figure, this would be the hanging wall over here on the right, and this would be the foot wall over here on the left. And here the hanging wall is being pushed upward, and so hanging wall up is reverse. Which principle allows you to determine the relationship between B and C? So B is here and C is here, so what is the relationship that tells you that C is older than B? Age of inclusions, superposition, cross-cutting relationships, or faunal succession? That would be cross-cutting relationships because B cross-cuts C and offsets it. What type of landslide is featured below? We're looking at this landslide. Are we looking at translational, rotational, a fall, or a topple? This is the rotational landslide because you can see the curved surface here. Remember, translational has a flat surface. It's not curved. And a topple or a fall will show rocks falling down or toppling. What feature is labeled A? So what is this feature here? Is that the crown, the toe, the main scarp, or the body? That's the main, that's the crown. The main scarp is this below feature here. It's pointing to the crown where you have all of these little cracks. So this is the crown, and then you have the main scarp below it. What feature is labeled B? So here is B, it's pointing to this main portion. Is it crown, toe, body, or main scarp? That is the body. So this is the body of the landslide right here. And what feature is labeled C? So on this diagram, here is C. Is that the crown, toe, body, or main scarp? That would be the toe. So this is the toe or the terminus of the landslide. It's the basically leading edge of where everything is moving. Continental convergence. Is this the Aleutian Islands? We're looking for examples here. Aleutian Islands, Chile, California, or the Himalayas? This would be the Himalayas. Divergent. Where would we see divergent? Would this be the mid-ocean ridge, Chile, California, or the Himalayas? This would be the mid-ocean ridge is where you're going to see divergent plate boundaries. Oceanic convergence. Aleutian Islands, mid-ocean ridge, California, or Himalayas. This one is the Aleutian Islands. Transform plate boundaries. Where would you find these ones? Mid-ocean ridge, Chile, California, or Aleutian Islands? This would be California. Oceanic continental convergence. Aleutian Islands, Chile, mid-ocean ridge, or Himalayas? This would be Chile. Chile has an oceanic continental convergence. Stratovolcano is found where? Is that Long Valley, Fresno, Mount St. Helens, or Hawaii? And Mount St. Helens is a stratovolcano. Shield volcano. It says Long Valley, Fresno, Mount St. Helens, or Hawaii. Maybe Hawaii is a shield volcano. Caldera. Is this Long Valley, Fresno, Mount St. Helens, or Hawaii? Long Valley caldera. Which of these is glassy? Obsidian, pumice, granite, or diorite? Obsidian has a glassy texture. And the last one here. Which one has a vesicular texture? Is that obsidian, pumice, granite, or diorite? That would be pumice. Alright, so this Kahoot will be available for you to play as many times as you would like. This is going to be on YouTube by the time you see this. And you can watch the YouTube video as many times as you like as well before you take the exam. The exam will open tomorrow on the 11th, and you will have until the 18th to complete it. Okay?